Binomial distribution. In this video, I am going to explain some properties of the binomial probability distribution. The binomial distribution is a discrete distribution. It has only two outcomes. These outcomes are labeled as success and failure. How do we identify the binomial experiment? We need to check four conditions. First one, the experiment consists of n identical trials. Second one, these trials should be independent. Third one, as I mentioned before, it has only two possible outcomes. The fourth, the last one, the success probability is always the same for each trial. If these four conditions are satisfied, it is a binomial experiment. Let me explain this example. A coin is tested 10 times. Then let me check four conditions. First one, identical trials? Yes, n is 10 here. Independent? Yes, tossing a coin is independent. Success and failure? There are only two outcomes, head or tail. Then success probability. How do we know the success probability? Success depends on our interest. Suppose we are interested in having head, then probability of H is 0.5. All four conditions are satisfied, therefore this is a binomial experiment. Go to the next example. Number of correct guesses at 30 true false questions when you randomly guess all answers. First one, in identical trials? Yes, here n is 30. Then independent? Yes, because we are guessing answers. Therefore, the trials are independent. Success and failure? Only two outcomes. What are those? Right and wrong. Then success probability. How many answers? Two answers. What is the probability of getting right answer? 0.5. Therefore, probability of success is 0.5 for each question because each question has only two answers and one is the correct one. Therefore, all conditions are satisfied. Therefore, this experiment is binomial experiment. Go to the next. A student is taking a multiple choice test that has 60 questions. Each question has 4 answer choices. The student randomly guesses every question. First condition, identical trial? Yes, n equal 60 because 60 questions. Independent? Because the student is guessing? Yes, the trials are independent. Success and failure? Only two outcomes. What are those? Right or wrong. Therefore, third condition is also satisfied. What is the success probability here? There are 4 answers. One is the correct one. Therefore, getting correct answer is 1/4. That is 0.25. All 4 conditions are satisfied. Therefore, this is also a binomial experiment. Go to the next. Tossing a coin until you get a head. How about this? We don't know n here. Why? We toss the coin until get a head. Therefore, this is not a binomial distribution. But if you check the other conditions, they are satisfied. Go to the next one. Asking 100 people how much they weigh. What do you think about this? Identical trials? Yes, it is right. N equal 100. Independent? Yes, trials are independent here. Only two possible outcomes. It is not satisfied here. Therefore, this is not a binomial distribution. You can go with the other one because we don't have success or failure. Therefore, it is also unknown. So, fourth condition is also not satisfied. Now, go to the next one. Tossing a coin until a head appears. Right, what do you think about this? First one, n. N is unknown. Therefore, this is not a binomial experiment. But other three conditions are satisfied. Now go with this example. When an opinion poll calls landline telephone number at random, approximately 30% of the numbers are working residential phone numbers. The remainder is either non-residential, non-working or computer fax numbers. You watch the random dialing machine make 20 calls. X is the number that reach a working residential number. What do you think about this? What is the N? It is 20 because we make only 20 calls. Independent? Yes, the calls are independent. How many possible outcomes? Each one has two possibilities, working and non-working. How about success probability? It's always 30%. Therefore, success probability is 0.3 for each calls. Therefore, all conditions are satisfied. So, this is a binomial experiment. How about this one? It is the same example, but x is the number of calls until the first working residential number is reached. Now you understand n is unknown. Therefore, this is not a binomial experiment, but other three conditions are satisfied.